everyone, and welcome to day 2 of notes, which is on trapezoids and kites. So starting off with trapezoids, a trapezoid is a shape with two parallel sides. And those two parallel sides we call the bases. And then they also have two legs. So it's a four-sided shape, two bases, two legs. So these will be our bases, and they will be parallel to each other. Woo. Parallel. And then the legs are these two on each end, and those are not parallel to each other. An isosceles trapezoid is a trapezoid like the one right there, but this one has the legs are congruent to each other. And you can see that it's marked right here. We just call that an isosceles trapezoid. It has two sides congruent, and specifically those sides are the legs. Next up, we have the isosceles trapezoid angle theorem. And this one says if a trapezoid is isosceles, then the base angles are congruent. So in our trapezoid, we have four sets of angles. This one, this one, this one, this one. Or not four sets, but just four angles total. The base angles are going to be the two angles lined up on the same base. So remember, this is a base, and then the top one is a base. Which means that these two angles at the top are base angles, and then these two angles at the bottom are base angles. And if the trapezoid is an isosceles trapezoid, then those pairs of base angles are going to be congruent. The converse of the isosceles trapezoid angle theorem is the same thing as the isosceles trapezoid angle theorem, but backwards. This one says if the base angles of a trapezoid are congruent, then it is isosceles. So pretty much just the same thing backwards. The isosceles trapezoid diagonals theorem says that a trapezoid is isosceles. I can't spell today. Hold on. Isosceles. Okay. If and only if the diagonals are congruent. So the diagonals would be the lines running through the trapezoid connecting opposite corners. So AD would be a trapezoid, or not a trapezoid, a diagonal. And BC would be another diagonal. Now, if this is an isosceles trapezoid, then AD would have to equal or be congruent to BC, and that would have to be true. Okay, next we have this trapezoid right here. It's an isosceles trapezoid, we're told it is. So we need to find all of those missing angles. So the first one I'm going to notice is I'm going to get R, because this is a base. And if this is an isosceles trapezoid, which it says it is, then our base angles are going to be the same. So R and S are both base angles. They're both on that same top base. So they're going to be the same. So angle S is 70, which means angle R is 70 degrees. So angle R, 70 degrees. Next, I need to find P and Q. Now, I know that they're going to be the same because they're also base angles, just a different set of base angles on this other base on the bottom. And I know that this is a trapezoid, so I know that all of the angles need to add up to 360 because it's a quadrilateral. So I'm going to add up all of these angles and set it equal to 360. So I'm going to do 70 plus, we'll call these two x and x. So x plus x has to equal 360. We'll add together our 70s, and that'll get us 140. We'll add together our x's, and that'll be 2x equals 360. We'll subtract that 140 over, and we get 2x is equal to 220. Divide by 2, and we get x is equal to 110 degrees. So remember that both of these angles are equal to x, so which means both are equal to 110, because we just found out x is 110. So angle P is 110, and angle Q is 110. So the next definition we're going to do is called the midsegment of a trapezoid. So the midsegment is a line through a trapezoid that has endpoints on the middle of the legs and is parallel to the bases. Now, what that just means, AB and DC are bases, and they are parallel to each other because they are bases. This midsegment, MN, is also going to be parallel to the bases. Also, this midsegment, MN, has endpoints M and N that are going to be bisectors, or they're going to be midpoints of these legs. So AD and BC are cut in half by M and N, which means AM and MD are the same, and BN and NC are the same. And I'm going to mark those with 2. So let's try number 3. We need to find the length of the midsegment. So we know that it is a midsegment, so we know that it's parallel to these legs, or to these bases. So I always like to mark those. So the formula for finding the length of the midsegment is going to be MN is equal to 1/2 AD plus BC. And this is in regards to this picture up here. Basically, all that means is this is our midsegment. It's going to be equal to 1/2 the first base, we'll call it base 1, plus the second base. So if I add both bases together, multiply by 1/2, that'll get what the length of the midsegment is. That is also called finding the average of the bases. So I'm just going to plug it into this formula. This is the midsegment I'm trying to find. So I'm going to do QU, because that's the name of our midsegment here, is equal to 1/2. We'll call base 1 12, and we'll call base 2 8. So this was base 1, this was base 2, and we just plugged in their lengths. We'll simplify this a bit, and we get that QU is equal to 1/2, 12 plus 8 is 20. Half of 20 is 10, so that's going to be what QU is. Doo-doo. Next, on to our next shape is called a kite. So a kite is a quadrilateral, 4 sides. And this one has with exactly 2 consecutive congruent sides. Now, what that means, consecutive means next to, not two. If we're talking about congruent sides that are consecutive to each other, they're going to be right next to each other. So using this picture of a kite, that would mean that CD and DE are the same, or that B or CB and BE are the same. Those would be consecutive. They're right next to each other on the quadrilateral if you were just going around it. Next, the kite's perpendicular diagonals theorem. This one says if a quadrilateral is a kite, then the diagonals are perpendicular. So here's my diagonals going through. We've got CE and we've got DB. They go right through that quadrilateral. Perpendicular means that they make right angles. So if my diagonals go through and they make right angles, then that would be a kite. The kite opposite angle theorem says that if a quadrilateral is a kite, then exactly one pair of opposite angles congruent. So if this was my kite and I was saying that these two are the same and then these two are the same, my pair of opposite angles that would be the same would be C and E. Just exactly one pair. The other angles do not have to be the same, just one. Okay, let's do this next example. So this shape is a kite, so that means that the diagonals are perpendicular. So we need to find these missing sides of our kite and then the perimeter. So if we know that this is a kite, then we know that the diagonals are perpendicular to each other, so they make right angles, which means it makes a bunch of tiny little right triangles that we can use to the Pythagorean theorem to find our missing sides. So I'm going to start with this triangle right here. So this will be A, this will be B, this will be C in our Pythagorean theorem. So I'm going to plug it into A squared plus B squared equals C squared. So A was 2, so that'll be 2 squared, plus B was 6, so that'll be 6 squared, and it's equal to C squared. Great. Simplify this. 2 squared is 4, 6 squared is 36, and that's equal to C squared. 4 plus 36 is 40, which is equal to C squared. To get rid of that squared on C, I'm going to square root both sides. So I end up with C is equal to the square root of 40. We do need to simplify that, so we are going to break it down. I'm going to do 4 and then 10. 4 breaks down into 2 and 2. 10 breaks down into 2 and 5. I'm just looking for pairs, so this pair of 2's is going to come out. So 2 square root 10 was still left under there with no pairs. That is my missing side. Great. So C here, that is going to be 2 square root 10. Now, on a kite, it has 2 pairs of corresponding sides, or not corresponding, consecutive sides that are the same. So this side and this side are going to be the same. I can tell that they're going to be the same because they look the same. So this one's going to be 2 square root 10 also. Now let's focus on this other right triangle, this one. So we'll make this one A, that one will be B still, and then this will be C now. So we'll have 8 squared plus 6 squared equals C squared. 8 squared is 64, plus 6 squared is 36, and it's equal to C squared. 64 plus 36 is 100, equals C squared. Square root both sides, and we get 10 is equal to C. So this missing side is 10, and this missing side is 10. Now I'm going to add all those up to find the perimeter. Perimeter is just you add all the sides together. So the perimeter is going to be equal to 10 plus 2 root 10 plus 2 root 10. Combine your like terms. These are going to be like terms, so that'll be 20. And then these will be like terms, so that'll be 4 square root 10. We don't add the square root of 10 to another square root of 10. It just stays square root of 10. We kind of treat it like a variable. And then that would be my perimeter. Whew. For number 2, I just need to find this missing angle. Since it is a quadrilateral, I know that it's all going to add up to 360 degrees. So I'm going to add all my angles up and set it equal to 360. So 116 plus 116 plus 48 plus A has to equal 360. It's a quadrilateral, should have 360 degrees. Add those 3 numbers together and I get 280. Plus A is equal to 360. I'll subtract that 280 over. And I get A is equal to 80. Cool. For number 2, I know that this angle is 90, and I know that this angle is 60. And remember that in a quadrilateral, it needs to have 1 pair of congruent angles. Since 90 and 60 are not the same, this missing angle, X, is going to be the same as this missing angle over on the left side, and we'll call that one X also, because they're going to be the same. So that'll be 90 plus 60 plus X, plus X has to equal 360. Again, quadrilateral should add up to 360. Automatically, that should be your setup. Combine your like terms. That'll be 150. Add these 2 together, and that'll be 2X equals 360. Subtract that 150 over. And we get 2x is equal to 210. Divide by 2. And we get x is equal to 105. Cool. Okay, we're almost done. We've got this last one here. Since we know that this is a kite, just need to find x, y, and z. Let's start with y. This triangle right here that I'm outlining in purple is an isosceles triangle. I can tell it's an isosceles triangle because it has two congruent sides. Now remember, isosceles triangles have two congruent base angles. My base angles in this case are going to be this one and this one. So which means y is going to be equal to 53 degrees. The next angle I'm going to find is z. Z is this angle right here in the middle. Now remember, the diagonals, when they bisect, they are perpendicular to each other, which means they make right angles. Now this is also going to be right angle because when you have perpendicular lines, every single angle on those four corners is going to be a right angle. So we automatically know that z is equal to 90. Now the last one we need to find is x. So this diagonal will actually bisect this angle at the top. So this angle and this angle are going to be the same. So we can say that x is equal to 18 degrees. Okay, the diagonal RB of kite RHBW forms an equilateral triangle with two of the sides. So let's draw our kite. It looks something like this. We'll call it HRWB. And we know RB is a diagonal, and it forms an equilateral triangle with two of the sides. And angle BWR is 40 degrees. So we're going to draw and label a diagram showing the diagonals and the measures of the angles. So here is my picture to start out. Great. Now, this is an equilateral triangle at the top. I know it doesn't look like it, but it tells us it is, which means all of these sides are going to be the same, which means also all of the angles are going to be the same. An equilateral triangle has all 60-degree angles. So this is 60, 60, 60. Great. Now this other triangle on the other side, this is an isosceles triangle. It has two congruent sides, but also that means it has two congruent angles right there and there. So we'll call those x and x. And in a triangle, we know that all of the angles should add up to 360, not 360, 180. So we're going to do x plus 40 should equal 180. We'll add together our x's to get 2x plus 40 should equal 180. Subtract the 40, and we get 2x is equal to 140. Divide by 2, and x is equal to 70. So these two missing angles are going to be 70 and then 70. And then that is our diagram with all of the angles labeled. And that's it for day 2. So we'll see you all back for day 3. Bye.